So last time we talked about how empirical formulas are ratios, right, of the different elements inside of a molecule, right? So we did that one quick example of hydrogen peroxide, H2O2. This is the molecular formula. Molecular formula is where you have the exact number of elements in a molecule. And then we have the empirical formula, which tells you the ratio. So H2O2, if you break it down to, or bring it down to the empirical formula, it's going to be just HO, because it's a 1-to-1 ratio between the elements. Okay, you guys remember that? Okay, now today we're going to be talking about how we can take the empirical formula and figure out the molecular formula. Okay, so if you guys want, please, you guys can write this equation down, because this is how you can find the molecular formula using the empirical formula. Just a quick fraction. So just jot this in your notes, and then we'll use it to solve 3.11. Okay, guys, so let me show you guys how to find the molecular formula using the empirical formula. Pretty simple. All we got to do is take first we need to find the molecular weight. So here it tells us about a compound, has the empirical formula C3H4 and the experimentally determined molecular weight of 121 AMU. So this is the weight of the actual compound, okay, the molar mass. Okay, so we're going to take the molecular weight, which is 121 AMU, and then we're going to put it on top of a fraction. So 121 AMU. After that, we are going to take the weight or the molecular or the molar mass of the empirical formula. So here's the empirical formula. We have C3H4, and we're going to find the molar mass of the empirical formula, and that's what we're going to put on the bottom of the fraction. Okay, so we just divide the actual weight by the empirical weight. So if you guys feel comfortable doing that, you can kind of zone me out for a little bit while I'm talking and just finish that up. But just find the molar mass of the empirical. So we got C3H4. And so carbon, we said, is going to be 12, right? Carbon has a molar mass of 12. You can just leave that. Let me write that. This is period 6. Have a good one. Bye, Allison. Bye. Bye, Allison. Okay, anyway, carbon has a molar mass of 12.01. We said we can do just 12. And then hydrogen has a molar mass of 1. So we can use that to find the empirical molar mass. So carbon is 12. So if there's 3 of them, it's 36. And then 4 hydrogen, so 4. So the molar mass of the empirical formula is 40 grams per mole. Okay, so we can just put 40 on the bottom of the fraction. And then this is going to give us our ratio. Now, we don't need an exact number for this because we're just kind of looking for an approximate ratio. So when you take a look at this, 121 divided by 40, about what number do we get? 3, yeah, this is about 3, right? So this tells us that the difference between the empirical and the actual is just about a factor of 3. So all we got to do is take the empirical formula right here, and then we're just going to multiply it by 3. So everything inside by 3. Okay, so we're just going to do carbon times 3. So there's 3 of them, so that gives us 9, and then 12. And there you go. That is your molecular formula. So that's how you find molecular using the empirical. All right. Any questions about that one? Really not too bad. Do you guys feel comfortable finding empirical formula using those percentages from last time? Okay. All right, so the reason I asked that is because if you look at 3.12, I actually stole this from an AP test from a couple of years ago. So you will have empirical formula questions on the AP test. So I'll give you guys about maybe 3 or 4 minutes. You guys can work with the person next to you. I want you guys to find the empirical formula for this compound right here using the percentages. And then see if you get there, see if you guys can find the molecular formula using the molar mass. Okay, so what we did last time is part A, and what we just learned is part B. So I'll give you guys about 4 minutes. Try that out, work it out with the person next to you, and then we'll go over the answer in a bit, okay? Alrighty, guys, so if you're finishing up, please feel free to continue working and just check your answers, but I'm going to start going over it for the sake of time. Okay, so the first thing that we want to do for part A is we want to turn all of the elements into grams. So we're going to assume a 100-gram sample, so we can turn all the percentages into grams. So it's going to become 38.7 grams of carbon. It's going to become 9.7 grams of hydrogen and 51.6 grams of oxygen. And then what we're going to do is we're going to use the molar mass on the periodic table to turn all of these guys into moles. Okay, so carbon is going to become about 3.225 moles of carbon. Hydrogen is going to become exactly 9.7 moles of hydrogen. And oxygen is going to become 3.225 moles of oxygen. Okay, so far so good? Cool. Okay, now we can set up the empirical formula by using these moles as our as our subscripts. So we're going to do C 3.225. We're going to do H 9.7. We're going to do O 3.225. And then we're just going to divide by the most common factor, or the least common factor is 3.225. And that will give us a mole ratio of CH3O. So this is going to be our empirical formula. Okay. Any questions on that one? Any issues? Alrighty, so that is our empirical formula, which we learned about last time. Now we're going to do what we did this time, and we're going to turn this into our molecular formula. So for the molecular formula, all we need to do is take the molar mass of the actual, so 62.1 AMU, and then we're just going to divide that by the molar mass of this guy right here, of the empirical, which you should get about 31, or exactly 31. That is going to give us a factor of about 2. And then for all we need to do is multiply the empirical formula. So this is the empirical formula. Multiply by 2. So you should get C2H6O2. And there you go. That is the molecular formula for this compound. Yeah.
So I started off by multiplying by C2.1. I got C2H6O2. I just divided that by 2.
Yeah, that works too. Yeah. So whatever method works best for you, as long as you can show mathematically it works, you're good to go. Yeah, I'm not a big stickler about how you solve it, and the AP test isn't either. As long as you have some calculations, that's good for work. It's a good way of doing it, actually. All right, any other questions? Chillin'? Alrighty, so now we're gonna move on to everybody's favorite thing in chemistry. If you guys took chem before, you probably know this term, stoichiometry. Okay, so this is how we're going to end today, basically. We're just going to do a bunch of stoic problems. And then next time we meet on Monday, the day before the test, or the class before the test, we're going to learn something called limiting reagents, which is just stoichiometry with extra steps. And then you have the exam on Wednesday. So most of the exam is going to be stoic. If you're good at stoic, you're good at balancing. I said this last time, but the test should be fine. Okay. All right. So I'm going to do a quick review of stoic. So if you guys are comfortable, you can, again, ignore me and then just try 3.13. But I'm going to take it step by step. Hopefully, I'm not just talking to myself, but I might be if you guys are good to go. But yeah, I'm going to just get into it. So whenever you guys have a equation on the AP test, just assume that it's not balanced. If there's no numbers in front, right? If there was like, this isn't correct, but if there was a number in front of one of the compounds, you can assume it's balanced already. But if there are no numbers, assume it's not balanced. So you're going to start off by balancing this equation. Okay, so we're going to start off by counting. So there's potassium, chlorine, and oxygen. And so we're going to balance this one out. You're going to see there's 1 potassium, 1 chlorine, 3 oxygens, 1 potassium, 1 chlorine, and 2 oxygens. Okay. So I'm going to go through the balancing a little bit quickly because we talked about this last time, but you're going to notice that you need more oxygen. So we're going to add some oxygens to the right side. So let's just double it for now, turn to 4. And then we need oxygens on the other side. So let's double this. That'll get us to 2, 2, and 6. Okay, so you kind of see how it's going to end. You put a 2 here, you double it, and then you're going to have to make this 3 to get it to 6. Okay. So again, it doesn't really matter the method that you use to balance it, but your coefficients would be 2, 2, 3. All right, now let's set up the Stoich problem. So in a Stoich problem, what you want to do is you first want to identify your starting value and whatever you're trying to find. So if you look at the problem, what's our starting value for this problem? Yeah, 4.50 grams, but you have to be specific of what? Yeah, potassium chlorate. All right, and then what you want to do is you want to determine the unit of measurement you're looking for. So what unit of measurement should you end up with in this problem? O2, but specifically what about O2? Yeah, grams of O2. Okay, so you want to start here and you want to end in the blue. Okay, so stoichiometry is just glorified dimensional analysis. You're just canceling out units and just trying to get what you want. So the first thing you want to do is if you're going from one chemical to another chemical, you want to turn everything into moles because moles is what this equation, the balance equation, is basically a mole ratio. It tells you the ratio of a molecule that you need in order to produce another one. So let's turn this guy into moles. So what we're going to do is we're going to set up a fraction, just like dimensional analysis. I want to get rid of grams, so I'm going to put grams of KClO3 on the bottom. And you want to turn that into moles, so we're going to put moles of KClO3 on the top. Okay. All right, so if you ever see grams and moles on the same fraction, your values are going to come from the molar mass. Okay, so if you ever set up a fraction and you have grams and moles, doesn't matter where they are, if you see them, you're going to get it from the molar mass of that compound. So I'm not going to have you guys do the math. I'll just give it to you guys just to save time. But the molar mass of KClO3 is going to be 122.55 grams per mole. So I'm going to leave that there for you guys so you can plug it in on your own. But let's go on to the next fraction. Now, if we do this, the grams of KClO3 are going to cancel out, right? Now, I don't want moles of KClO3, so I got to cancel this guy out too. So I'm going to put moles of KClO3 on the bottom. And then you want to turn it into the moles for the fraction or for the compound that you are looking for. So we said we're looking for O2. So we're going to put it on the same fraction as O2. So we're going to put moles of O2 on the top. Okay. Now, if you ever see a fraction where you have moles and moles of different chemicals, your values are going to come from the balanced equation. So just take a look at the chemical equation that you balance, and that's where you're going to get your ratio from. Okay. So I'll leave that for you guys. And then for the last fraction, again, you don't care about moles of O2. You want grams of O2. So what we're going to do is we're going to get rid of moles of O2 by putting it on the bottom. And then you're going to put grams of O2 on the top. And if you see grams and moles on the same fraction, where do you get your numbers from? Sorry, I heard like, not the balance equation. Balance equation is moles and moles. If you see grams and moles, you get it from, yeah, the periodic table. The more specific term is, yeah, molar mass. Okay, so just remember that. If you ever see grams and moles, you always get the numbers from the molar mass. Okay, and I'll give you guys the molar mass of O2. It's 32 grams per mole. Okay, and The reason why we do this is if you notice, all of the units cancel out with one another. That's how we convert. That's stoichiometry. Just converting from one compound to another in a reaction. All right, so I'm gonna give you guys a minute, see if you guys can plug in your values, put the numbers in the right positions, see if you can calculate it out, and let's see if you guys get the right answer for this stoich problem. The numbers in, so you guys should have put 122.55 on the bottom because it's grams per 1 mole. Okay, for the second fraction, your values come from the balanced equation. So if you look at O2 has a 3 in front, so you put a 3 on the top, and KClO3 has a 2, so we put a 2 on the bottom. And then for this one, 32 goes on top because that's what grams is, and it's per 1 mole. So those are your values. Now, when you're punching these into your calculator, super easy. Everything on the top you multiply, everything on the bottom you divide. So if you plug those into your calculator, for your final answer, you will get 1.763 grams of O2. Something like that. 1.76, 1.8. If you're in that ballpark, you're good to go. All right. Any questions on that one? All righty. Okay, so let's move on to 3.14. I'll leave this up here if you guys are copying it down. Now, sometimes on the AP test, they will have you write the chemical equations. Sometimes they'll be big jerks and they won't give you the equation written out for you. So I'm going to give you guys about 2 minutes. See if you can work with the person next to you and see if you can use this word problem basically to figure out what the chemical equation is. Just a hint, you're going to need to know ionic compounds, which is why we did the naming last unit. So hopefully you have that to refer back to. But just see if you can get it. And then once you get it, try to balance it out because you'll have to balance it. But in 2 minutes, I'll go over the equation just to make sure we're on the right page. I'll balance it and then we'll go on to the stoich. Okay, so try 3.14, just writing the equation and balancing it, at least for now. Okay. Okay, so for this one, you should have balanced it pretty easily. You just need a 2 in from the lithium hydroxide. Lithium hydroxide has a molar mass of 23.95. If you round that up to 24, it should be okay. Should be still in the same ballpark. And then just kind of plug and chug the way that we normally do. Okay. You were looking for carbon dioxide, so make sure that you use 44 for your molar mass. And you should get something around 0.919. We got like 0.92, 0.95. That's totally fine, as long as you're close. Alrighty, any questions? Easy peasy? I feel like you guys are a lot more comfortable with stoic than the other stuff that we've been doing this last year. So I gotta make this harder then. Alright, well, I'm gonna have you guys just do one more on your own. So this is about as hard as the stoic is going to get on the AP test. I don't think they will ever put something harder in terms of balancing, setting up the equation, things like that. This is probably as tough as it's going to get. And this is the last thing that we're going to go over. So if you guys finish this, you guys can work on your homework and I can go over some homework questions. I'll also pass back your tests once we're done with this problem. So I'll give you guys like 5 minutes, try to set up the equation. The balancing might be a little bit tricky, but I believe in you guys, and I think you can do it, okay? You have my full trust. So try it out. We'll go over it, and then I'll pass back your tests, and you guys can work on your homework for the rest of the class. Yep. Anyway, but that's what it is, guys. Yeah, that's pretty much as difficult as your test is going to be in terms of the stoic. But you never know what curveballs I might throw at you guys. So yeah, next time we meet, just remember your homework is due, so just make sure you guys work on it. I think the first part of 3A is the stuff that we went over last time. And then the second or the end of 3A, that's where like the stoic and stuff are. Next time we meet, we're going to learn something called limiting reagents, which is just stoic. And so you might have seen that already, so it's not too bad. But yeah, that's pretty much it for today. You guys can work on your homework. Let me know if you have questions or you want to go over anything. And I will start passing back your exams now.